Welcome to Next Gen Manufacturing. Today, we are diving into a piece of tech that's completely changing one of the most important parts of machining, getting that perfect surface finish. Ever since machinists started cutting metal, this has been the big question. Do you want that perfect mirror-smooth surface? Well, that's going to take forever. Or do you need the part done fast with a finish that's, just okay? It's always been a trade-off. But what if it didn't have to be? So before we can really get into the solution, we've got to understand the problem. The old way of doing things, usually with a tool called a ball-end mill, basically forces you into this corner where you have to choose between speed and quality. But there's a new promise on the horizon, one that says you can have it all. Think about it like this. Using a regular ball-end mill for a super high-quality finish is like trying to mow an entire football field with one of those tiny little push mowers. Sure, you can get it done and it'll look perfect, but it's going to be painfully slow, right? You're doing endless passes. The goal, of course, is to get that same perfect lawn, but way faster. The old tools make you compromise. The new goal is to get rid of that compromise completely. Okay, so how do we actually do that? How do we break that old compromise? Well, the answer is in the tool itself. And believe me, it's at the heart of this whole manufacturing revolution. All right, let's meet the star of the show, the multi-axis finisher. Now, you might hear people call it a barrel cutter or a circle segment cutter. They're all talking about the same thing. The idea behind it is actually pretty simple, but it's brilliant. It uses a very large cutting radius, and that single design choice is what lets it do one of two amazing things. Either get a way better surface finish in the same amount of time, or get the exact same surface finish in way less time. So you're probably wondering, how does just having a large radius do all that? Well, the secret here isn't some new space-age material or a crazy fast motor. Nope, it is all about the geometry. The incredible power of these tools comes directly from their unique and, frankly, kind of weird shapes. And there are four main shapes, each for a different kind of job. You've got the barrel form with the radius on its side, the lens with a radius on the end, and the oval, which gives you a bit more flexibility. But let's be honest, the one that often steals the show is the taper form. Its shape allows for a truly massive effective radius, and that's where you see these just mind-blowing performance boosts. We've talked about what it is and how it works, but let's get to the good stuff, the results. I mean, how much faster are we really talking about? How much smoother? It's time to talk numbers, and it all boils down to one critical metric. Okay, this right here is the secret sauce. Go back to that lawnmower analogy. The distance you move the mower over for your next pass, that's your step over. And the tiny little ridge of grass left between the passes, that's the cusp height. And that's what determines how smooth your finish is. Because a multi-axis finisher has such a large radius, you can make your step over much wider, while leaving the exact same tiny cusp height. Wider passes mean fewer passes. And fewer passes, well, that means huge time savings. And here it is, the payoff. We're talking about a 400% wider step over for the exact same quality of finish. Let me put that in perspective for you. If your original tool path was, say, a mile long, you could now get the same job done with a tool path that's just a quarter of a mile. This is what the industry calls the benefit multiple, and it is the source of this incredible efficiency. It's a total game changer. So what does this actually mean for the machinist running the machine? It means you get choices, real strategic choices. You can keep the cycle time the same and get an unbelievably better finish. Or you can say, the original finish is good enough, and just slash your cycle time to a fraction of what it was. And of course, there's a happy middle ground. Reduce your time and improve your finish. You get to pick the strategy that makes the most sense for that specific job. Now, all this sounds absolutely fantastic, right? But what does it really take to get one of these things up and running in a real shop? This is probably the very first question that pops into the head of any programmer or shop owner. I mean, this is not a standard tool, so can my standard software even handle it? And the short answer is yes. You definitely need modern CAM software that knows how to handle these special shapes. Now, a few years ago, that was a huge hurdle. Only a handful of super specialized programs could do it. But today, support for these tools is baked right into major software packages like Mastercam and HyperMill. It's made the tech so much more accessible. It's also really important to know where these tools are at their best. I mean, they're called finishers for a reason. They absolutely dominate on wide open surfaces and big, smooth, sweeping contours. They are not what you want to use for digging into tight little corners or carving out tiny, intricate details. It's all about using the right tool for the right job. So let's pull back for a second and look at the big picture. This isn't just about one cool new gadget. This is about a real shift in how we think about manufacturing. So why is this all happening right now? Well, the technique has actually been around for a handful of years, but the reason it's exploding in popularity right now is because two critical things finally came together. First, our ability to actually manufacture these complex tool geometries, and second, the widespread availability of CAM software that knows how to use them. It's that convergence that's kicking off this whole revolution. And really, this quote just says it all. This isn't some small incremental step forward. We're talking about a technology that is ready to completely redefine what is possible in the entire world of finishing. It's changing the fundamental rules about speed versus quality. And that kind of leaves us with one final thought to chew on. We've just seen how one single breakthrough in tool geometry, when paired with the right software, can absolutely shatter a compromise that's been around for decades. It really makes you wonder, if one tool can change the game this much for finishing, what other rules of manufacturing are about to be broken next?